Earlier, we talked about element-wise matrix operations, and that actually covers a lot of the math involved with neural networks. But when it comes to multiplication, things can get a little more complicated. Here, we're multiplying a matrix by itself to square its values. If you look at the answer, it's fairly obvious where each value comes from. 1 times 1 equals 1, 2 times 2 equals 4, 3 times 3 equals 9, and so on. This element-wise multiplication is a valid operation, but most of the time when people mention matrix multiplication, this isn't what they mean. Instead, they're usually talking about a special operation called the matrix product, which ends up looking like this. Now when you look at the answer, it's probably not so clear where these numbers are coming from. Here's another difference. We said element-wise matrix math required matrices of the same size. For example, this element-wise multiplication works fine. But if you tried to find the matrix product of those same matrices, well, you can't. It can be confusing, and you're pretty much guaranteed to mess it up at least a few times when you start building neural networks. But this is actually one of the most common operations you'll use, so it's important to understand. Okay, so how do we actually calculate the product of two matrices? Well, before we deal with matrices, let's start with just two equal-length vectors. One operation we can perform on these vectors is called a dot product. For this class, you won't need to know how dot products are used, but there's a link below the video if you're interested. To find the dot product, we first multiply the corresponding elements of each vector. So the 0 times the 1, the 2 times the 7, and so on. Then we add up all those results to get a single number, in this case 180. This operation basically lets us take two vectors of any length as long as they're equal and convert those vectors into a single number. So how does that help us multiply two matrices? It turns out, to find the product of two matrices, we take a series of dot products between every row in the left matrix and every column in the right matrix. That's really important to remember. Whenever you multiply two matrices, you're actually dealing with the rows of the first matrix and the columns of the second matrix. I'll go into more detail about why that's important later, but for now, let's work through an example. To find the product of these two matrices, we'll start by taking the dot product of the first row of the left matrix and the first column of the right matrix. For now, just ignore all these other numbers. Then we can pretend this row and this column are just two equal-length vectors. Now we find their dot product, with corresponding elements moving across this row and down this column. So just like before, we have the 0 times the 1, the 2 times the 7, and so on. The dot product between this row and this column becomes one entry in the result matrix. You put it at the same row and column indices as the row and column you just used to calculate it. So since we used row 1 in the left matrix and column 1 in the right, the answer goes here in row 1, column 1 of the new matrix. If we had instead used row 2 in the left matrix and column 3 in the right, the answer would end up here in row 2, column 3. Okay, all that work was just to find one element in the new matrix. To get the whole result, we need to find dot products for every row in this matrix, combined with every column in this one. There are 3 columns in the second matrix, so that means we need 3 dot products for each row in the first matrix. And since there are 2 rows in the first matrix, that means we'll need to find a total of 6 dot products for this one matrix multiplication. We have 1, so to find the other 5, we just repeat the process for each row-column pair. So the dot product between row 1 and column 2 becomes the entry at row 1, column 2. Then we finish off this row by finding the dot product between row 1 and column 3. We do the same thing for the next row, finding dot products for row 2, column 1, row 2, column 2, and row 2, column 3. With all that done, we finally have the result of the matrix multiplication we actually wanted. That was quite a bit of work. The answer matrix only has 6 numbers in it, but to find those 6 numbers, we did 24 multiplications and 18 additions. As your matrices grow, it gets even worse. But I guess that's why we do stuff with computers, right? I mentioned earlier how there are times when taking the product of two matrices won't work. In the next video, I'll talk more about that and give you some important tips about matrix multiplication.